2 parts hydrogen, 1 part oxygen. Without it, we don't exist. Life on Earth does not exist. Water is seemingly everywhere we go. Whenever we decide we need some, we just turn on the faucet, and there it is. Yet so much that humanity has developed over the last 200 years is doing quite a bit to pollute and reduce our drinkable water supply. And for most of the world's population, fresh, drinkable water is rare and hard to find. We have built a concrete jungle. Every single day, trillions of gallons of water is pounding highways and byways, skyscrapers and tarmacs, picking up all the pollutants that have gathered on these surfaces. Once it hits, water gathers all these chemicals and toxins, floods the surface, then runs toward whatever waterway is downhill. It's called runoff. The amount of runoff is directly affected by the permeability of the land. In other words, how easily the water can be absorbed by the land. The more permeable the land, the more water can be absorbed into the ground, where rocks, soil, and minerals naturally cleanse the water. The harder the ground, the lower the chance that the water will be absorbed and the greater chance that the water will gather toxins and head to the river. That means the waterways of our world become more and more contaminated with toxic waste. Toxic waste in our waterways can create all kinds of environmental disasters.
So, for example, one of the problems that the rivers in Virginia have been intersexed fish. And so fish that had female parts, not separate male and female fish. And one of the types of chemicals that can do this is create this problem is an estrogen mimicker. And paint is an example of an estrogen mimicker. So if you have rain hit a surface and some of the paint gets pulled off of that, and then you expose your freshwater system to that, you could be changing the sex of these fish, and that can really affect a population. Runoff occurs when precipitation flows over land. So what are the different types of precipitation that we get in Virginia?
Holly Houts, an environmental outreach educator for VCU, is helping students at Charles City Middle School understand water runoff by taking it directly to their own school.
I calculated the area for each part of the halls, and I added up those areas. So the total area is 130,747 square feet.
Over time, students begin to calculate for themselves just how much water gathers on the roof of their school and how much of it is wasted and possibly polluted as it heads toward the next river or stream.
So how many gallons of runoff, and I used the same equation that you guys use, and it's almost 300,000 gallons just in 1 month, so that's a lot.
Holly and Ann Wright have spent a lot of time studying this phenomenon at VCU's Inger and Walter Rice Center for Environmental Life Sciences. And they have been instrumental in demonstrating how the effects of water runoff can not only be avoided, but be turned around to create very positive outcomes from a good rain. Today, students are seeing how a green roof full of soil and vegetation can absorb water and sunshine, grow vibrant plants, and remove many toxins. Holly and Ann are showing the students how the shape of the roof can collect water runoff into contaminant ponds. Instead of pounding the pavement and gathering pollutants, this rainfall has a place in a life-producing garden pond.
Water strider, excellent. Go put them in the tank.
That was raw.
And this is actually a small retention pond, basically, for some of the excess runoff that can come off of our green roof. So basically, any of the plants on the green roof that don't take up some portion of the water can be returned here. And it's very neat because it creates a habitat. We're just now starting to get into spring, so our plants aren't fully grown, but I can see that they're starting to bud out a little bit. The plants will grow here. We'll get colonization by dragonflies. We'll see some frogs coming in, and we've seen them out here mating before and laying their eggs in these ponds. Sometimes we do see a couple mosquitoes, but generally we see different insects coming in that would eat the mosquitoes. So dragonflies, water beetles, and we've also seen quite a few snails. Now, if this tank gets too full, it will start a stream across the concrete there, and it'll move out and water the lawn. The backyard here is the James River, and so we wanted to find ways to manage our runoff. We don't want the runoff to move straight over the land and go right into the river. We want to find ways to retain it here to have it absorbed by plants.
The folks at the VCU Rice Center are also showing how parking lots and roads can transform from being part of the problem to being part of the solution.
I am standing on a semi-permeable structure, and part of it is under gravel and also part of it is under vegetation. And what this does is, instead of having a solid roadway that wouldn't allow water to percolate down through, we've actually opened up spaces where when it rains, the rain will be able to filter down through the soil and filter down through these rocks, and will be able to move into the earth instead of moving over top of the roadway and entering a waterway as runoff. So as we're driving our car down this roadway, we could be pulling in dust from other places on the road. We could be pulling in particles of pavement, oil, residues, and chemicals from the motors. And so instead of that moving into the waterway as runoff, it can actually move down into the earth and be processed there and basically be filtered out.
The material at the Rice Center is made of recycled plastic set in an interlocking grid and filled in with gravel. Vegetation and grass can also be part of this parking lot.
Here's water being poured on traditional asphalt. Notice that it runs downstream, not into the ground.
At the Science Museum of Virginia, staff scientist Eugene Maracus has been working on runoff solutions for many years. However, part of the Science Museum's parking lot is made of pervious concrete. The result of water flowing here is quite different. Here we see a very different outcome. The water is absorbed into the concrete. In fact, 1,500 gallons of water can be absorbed into the concrete in 5 minutes. This pervious concrete is a significant game changer in the effort to prevent toxins and pollutants from entering America's waterways.
Not having the runoff, if you think about pollutants like oils and greases and nitrogen and phosphorus and pesticides, they don't go into the storm system, they go down into the ground, and there are bacteria down there, and also the kinds of rocks that are there begin to remove those materials, and then that water settles down into the groundwater. If you had runoff in a conventional parking lot covered with asphalt, that water would flow into a stormwater, and then that would go into the river, and that carries along all the pollutants. It's a bit more expensive than traditional concrete. The benefits, though, are that it prevents the pollutants from going into the rivers. Number two, it's lighter in color. And so being lighter in color, it reflects a lot of the heat rather than absorb the heat.
The Science Museum set up a small ravine that sends the water that has been absorbed and cleaned by the soil and rocks underneath the pervious concrete, so it can be tested and sent on to the James River.
This is worth doing. It may cost more initially to install, but in the long run, it's not only good for the pocketbook of the consumers, but also for the environment.
Another significant long-term benefit to the prevention of sending polluted water into our rivers and streams comes with the biggest of storms. Asphalt parking lots that get inundated with heavy rains often flood, causing enormous damage to the parking lot itself, vehicles, and buildings. With more and more pervious parking lots in place, those millions of dollars in damage to cars and infrastructure will be greatly reduced. Students are making this happen with the bioretention pond they created here in Chesapeake and rain barrels they are using in their service learning projects to save water and use for plants. And the water, the precious water that sustains life on Earth, can be cleansed as it makes its way to America's streams and waterways.